Having fun. This is a thing that I did when I was like 12. I used to get the Radio Shack electronics kits with the little bendy spring terminals. Those are fabulous. And one of the projects they had in there back when I was a kid was a thing on how to learn Morse code and how to make your own little Morse code buzzer. And the kit didn't come with a buzzer, it had a relay. So this is kind of cool, and I figured I'd share this one with you guys because we're just playing around here. We've been making official videos all day, so this is just a fun one. Now, I've got a handful of relays, like this, little Omron relays, 24-volt coils, and this is the pinout on them. They're a standard 8-pin relay, so you've got 2 and 7 do your coil, 1 and 8 are your input contacts, 3 and 6 are normally open, 4 and 5 are normally closed. Now, what we're going to do is connect the into the coil, so coil goes to power on 2, out of the coil to one of the inputs, so 7 and 8 get jumpered, and then back power out on 5. So what will happen is you apply power, the coil is energized because this is connected. The coil moves the armature, this opens, and that kills the power to the coil. So the armature falls back down, and that's powered again. And it'll cycle, and it'll just slam that thing as fast as it can. So through the magic of television, we already have one right here. Look at that, isn't that fabulous? It's lovely. Cute little relay right there. Now this is a standard 24-volt Omron relay, and we've hooked it up according to the schematic back there. So this is what it does. If you put on the table here, and we'll grab our manly lab test power supply of science, and we'll crank this up to 24 volts. Ta-da! It buzzes. The frequency that the relay will buzz is dependent on the mass of the armature. So if you do this to like a big clunky relay, it will go like boom, 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 boom. It'll be really, really slow. The problem is I wanted to do it with a contactor, and we can't because this doesn't have a set of normally closed contacts on it. Some contactors do, but I don't have one here at the lab that does. So we did it with a little one here. This is 24 volts, but what's really cool is this is how well built these relays are. This is kind of cool. This power supply will put out 120 volts of DC. So I can just grab this knob. It's a lot louder now, and it works good, but it won't die. So that's pretty cool. There is a side effect to this. And those of you outside of, the cities will be able to make this work. If you have cable television, this won't work. If you watch TV on your computer, this won't work. But if you have an old school television set that uses radio waves, this will work. If you are, say, a 12-year-old boy living in small town America who has built one of these in your upstairs bedroom, and your dad is perhaps watching the races on Sunday on TV, and you're upstairs going beep, 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 beep. Dad gets pretty angry in a hurry because this is actually a very small, very simple spark gap transmitter, and all it generates is that noise throughout every kind of radio transmitter in the house, or every kind of radio receiver in the house, and it messes up TV pretty bad. So yeah, if you want to mess with your dad who's trying to watch the game on Sunday or whatever, then this is a fun way to do it. But yeah, that's your basics of fun with relays and how to build your own spark gap transmitter. So you guys have fun. I'm Chris Bowden at the Geek Group, and I'll see you next time. Bye.